Hello everyone. Last class I discussed about distance versus time graph and velocity versus time graph, and we learned how to calculate average velocity. Today I would like to discuss instantaneous velocity. For that I would like to show one video clip. Let us watch that first.
In this lineup has run 100 meters in less than 10 seconds. Bolt, Gay, Powell, 4, 5 and 6. They're away. Terrific start by Daniel Bailey. Usain Bolt though getting into his running. Here he comes. Usain Bolt challenged by Tyson Gay. Usain Bolt 2 clear meters. Tyson Gay in second place. And in third place Asafa Powell.
9.58! Smashing the world record. Unbelievable! He's done it again! A year later, rewriting the world record again!
Let's look again. Gay, Bolt got a good start, not quite as quick as some of the others in the race, but Steve, once he gets into his running, we've never seen the like.
No, you cannot understand what is going through the rest of the minds of the other sprinters. Tyson Gay is running a time that is absolutely sensational, and he's been dismissed. Literally dismissed. He's still looking around at this speed as well. There may be even more in the tank for this man if he really pulls all the stops. Look at him. Where's Tyson? He's thinking, where is he? Well, he's a long way back, Usain. He is a long, long way back.
Well, Usain was looking at the clock there. He didn't look at it first in Beijing. He is this time. He got a reaction time of 0.146. The 3 men were quicker. Gay, though, very fast running indeed. He pretty much held him over the last 10 meters or so, but of course by then Bolt had flown away. Just to complete the stats on it, the wind speed was well within the permitted limit, but it was just slightly behind them, which helped at plus 0.9 meters per second. And here is the photograph that will flash around.
Yeah, what we saw, that is Olympic world record 100 meters men. Usain Bolt gave 9.58 seconds, so that is the top speed in the world record 100 meters run. So if you can observe carefully the race, now finally here we got that. Yeah, so here you highlight these two numbers. So this is the world record time. So the world record time which is given there, it is 9.58 seconds. 9.58 seconds. So if you can notice at here, the speed of the Usain Bolt is given that speed equal to 37.6 kilometers per hour, or in terms of meter per second it is a 0.9 meter per second. Now what the speed here we got, so that is the average speed. It is the average speed. Yeah, we can calculate that average speed. So how we can calculate that average speed? We know the time. So time t equal to 9.58, and we know the distance d equal to 100 meters. So this is a 100 meters race. So to calculate speed, we need this is two things only. Speed equal to distance upon time. So here distance equal to 100 meters upon 9.58, so meters per second, and we will get that value in terms of approximately 0.9 meters per second. So Usain Bolt covered 0.9 meters per second. So what we calculate here, that is average speed. Again I am telling. So this is average speed or average velocity also you can say, because it is a 100 meters race. So they have to run in only one direction. So we can say here it is the average velocity also. But suppose if I ask a question, suppose if I play this again, the same rays. Now this is the starting. Initially they are at 0. Now here you can see a timer is running. Now the timer at here shows that 6 time is happening at 6 seconds. Now at this time I want to know what is the velocity of the Usain Bolt at this second, at this time. What is the velocity of the Usain Bolt? How can we calculate that? Still it is running, so but at this second I want to calculate the velocity of the Usain Bolt. So that velocity we used to say instantaneous velocity. It's instantaneous velocity. So instantaneous velocity we define as velocity at that particular time. So to define this instantaneous velocity, we need to learn different mathematical technique. So today I would like to talk about instantaneous velocity. Again I am telling, instantaneous velocity is velocity of the object at that particular instant. So if object is running, if object is moving, its velocity, I would like to know the velocity of the object at that particular instant. The velocity of the object at that particular instant. So that velocity we define as instantaneous. Instantaneous velocity. So let us understand how to calculate instantaneous velocity. So this is a non-uniform motion graph. Non-uniform motion graph. And we know how to calculate the velocity of this distance versus time graph. So this is the distance versus time, and if you can calculate the slope between the points P1 and P2, so we can able to calculate the average velocity. So velocity average, we used to write this formula, x2 minus x1 upon t2 minus t1, or velocity average equal to position final minus position initial upon time final minus time initial. So here final position at 27.4 minus initial position, it's at P1, here it equal to 10 upon time is 7 minus 5. So we solved this already. So here I got it 17.4 upon 2. So if we can solve this, so that gives us average velocity. But we need to find that what is the instantaneous velocity. So for that, let me take to you one graphical model. So I would like to talk a new things related to mathematics. So first of all, let me explain about this everything. So now whatever I talk, that is entirely goes to mathematical language. So at here I am having a graph. So this green line, is a graph for x square. So for a function, so x square is a function, mathematically can call that as function x square. So the graph is plotted for x square. It means, suppose if f of x equal to x square, it's a function for different values of x equal to 1 and x equal to 2 and x equal to 3 and x equal to minus 1 and x equal to minus 2 and x equal to 0. For different values of x, So what is the value of f of x square? So here it is 1, here it is 4, here it is 9, here it equal to 0, here equal to 1, here it equal to 4. If you can plot by using these values for a graph, so we will get this green line. So that is the graph for x square function. Now in this x square function, if I take any 2 points, as per we need to calculate that slope for velocity. Since it's a mathematical function, I don't call this as a velocity. Right now I will call as a slope or gradient. So slope formula, what we can take, first we need to take any 2 points. So here that is the point and this is the point, and slope equal to the change in the y component delta y upon change in x component. So here change in delta y component shows as 1.60 upon change in x component is equal to 1.0. Now if you can calculate delta y by delta x, which is also known as slope, which equal to here 1.60. If you can closely observe at here, so this function is calculating at here. So if I change the points, in the graph, if I change this point in the graph, so what happens? The slope already calculated gets changes. If you can see, the slope is changing. And here I would like to say this line, the line where it is touching on the graph at 2 points, so this line we can call as secant line in mathematical term. That is line is known as secant line. The secant line touches the graph at 2 points. So with the help of that 2 points, we can able to find the slope of that particular segment. We can find it out. Now suppose if I bring this line close, if I bring this line little close than to earlier line, now here you can see the slope has changed. And if you can take the zoom in section of that particular section, now if you can see the segment difference, here the y segment equal to 0.956, which is small, the difference in the y component from here to there, and x component difference here equal to 0.729. If you can divide that delta y upon delta x, here we got a slope 1.32. So that is the slope of that segment. Suppose if I bring this point further close, now if I bring this point further close, now here you can see the y segment and x segment, they already changing. Now if you can take that as zoom in, now here you can see the graph, the very small change in x and y. So x and y values has changed further less. Now again I want to decrease. Now I am decreasing now such a way like that. Now they came almost all close together. That is a very one smallest segment. Now if you can take out zoom in, if you can see how small it looks like. So we are feeling that the both are almost all close, but they are not close. Since I have option here, I can zoom in and we can show that. Now I am asking a question. So what is our concept? That so we need to find instantaneous velocity. So for instantaneous velocity, velocity at that particular point. Till now we can able to calculate that slope by using 2 points. We are able to calculate slope by using 2 points. So what happens if I bring these points one over other. So if I bring these 2 points one over other, it means instead of having 2 points, still it is having 2 points. Now instead of having 2 points, now if I have 1 point only, now still it is showing, since they both are not at all close. Here you can see still they are little far away. We can able to calculate that slope with the help of computer, since they are still close. Now if you want to see by zoom out, see, so they are not as close, there appears as a single, but when you can take at here, still these 2 points are appears to be separate. We can find out the slope. Now the real task comes. Suppose if I bring this point over the other, suppose if I bring this point over the other, still it is coming. So let me bring this point exactly over the another point. Now, so this is the key point. Now earlier the 2 points are separated, so we found that the slope by using this line. Again I bring the 2 points little closer, again we found. Now again I bring the further close. Now finally I reach at a location where the 2 points are one upon another. Now if I ask the computer, so what is the calculate of the slope? Now here my software is showing that the delta y, the change in y component here, it is almost all negligible. After 0 so many, it is showing difficult to count to me, 0.0000000000278, that is the difference in the y component. But the x component, so the x component, the difference is exactly 0. Suppose if you divide this delta y by delta x, what we can get? It is asking a question mark. How can I get that? So but this is our instantaneous at that particular point. So this is what all we need. It is nothing but instantaneous. It is nothing but instantaneous. This is all what we need. So till now what we have been following about the slope delta y upon delta x. So this is not working at here. So if it is not working, we need to change to a new technique or to new method which was introduced by the Newton in the name of calculus. So in that particular, so we are using a word that known as limits. Suppose here I am having option show limit for delta x tends to 0. Now here I change my operation. Earlier we are calculating only delta y upon delta x. So if I switch off that, now you can see delta y upon delta x. It is asking something. What is this? It's a question mark. So this one we cannot calculate that. So no result. But if you can take an option, here that option is, here it is, show limit. So here we are seeing a different mathematical terms which is known as dy by dx. I will tell what is this. This is nothing but limit delta x. Here the x is the term, delta x tends to 0, delta y upon delta x. Till now this we know how to calculate, but over that we need to operate this operation, limit operation. So that limit delta x tends to 0, delta x, the change in x value is going to be 0. The delta x is going to be 0. Now this everything together we will express in the simplest manner dy by dx. This is only nothing but we can call as differentiation. So finally I can say that to calculate the instantaneous velocity, we need to change a mathematical technique, so that is known as differentiation. So when we do differentiation, so how the things get changed, you observe. So this is the high zoomest point I have taken. Suppose if I zoom out from this, if you can see how the graph changes. Oh. Still I want yeah, this is something we know. Now earlier it was touching at 2 points, and we call this as secant in mathematical language, but now it is touching at 1 point. To the curve it is touching at only 1 point, and we should know what this line supposed to call. Yeah, it's nothing but tangent. A line which is touching a curve or a circle at a single point, that is nothing but tangent. So to calculate that instantaneous velocity, suppose if this is my displacement curve, or this is my position versus time curve, or displacement versus time curve. So to find out that instantaneous velocity, so what shall I do? I need to calculate slope of the curve for tangent. So that slope, how can I calculate? I can calculate by using a mathematical operation that is known as dy by dx. So here y is nothing but the variable which is along the y-axis, and x is nothing but the time which is present on the x-axis. Suppose if it is velocity versus time, so our things gets changes. If it is a displacement versus time, on the y-axis it goes to displacement. We are representing displacement as x. On x-axis it will goes to time, and this is, let me take as displacement versus time graph. And the difference at here we can call delta x, and the difference at here we can call delta t. So delta x upon delta t we are calling as average, velocity average. But to calculate the instantaneous velocity, so we represent that instantaneous velocity as v equal to, we need to do certain operation. That operation nothing but limit delta t tends to 0. So the change in the difference is almost all 0. So the change in difference on the time is negligible 0. Then we can write upon delta x upon delta t. Now this mathematical operations how we can do? So that we can do by calculating all the limits with the help of the entire expression I am going to change. So this I can write in a simple manner. This is nothing but dx by dt. So if we can do dx by dt, which gives to me velocity, or which velocity this is? This is instantaneous velocity. What the instantaneous velocity means? Velocity at that particular time, at that particular second. Now this how we can read dx upon dt. So the dx upon dt we can read the displacement upon time. So finally I can conclude that, so if these are the average velocities for the position versus time graph, but I want to find the velocity of a tangent line which is touching a curve at one location, at only one particular point. So this gives to me instantaneous velocity. To find out instantaneous velocity, we are representing instantaneous velocity as v, as lowercase v equal to instantaneous velocity v equal to, here we need to do certain operation that known as limit delta t, here the difference delta t tends to 0. So here delta t means nothing but difference between the 2 points. So but at this location the difference goes to 0, the delta t value goes to 0, and here we need to divide delta x upon delta t. So the difference in the x component upon delta t, and this everything we will write in terms of velocity v equal to dy by dt, sorry dx by dt. Here x is position. So here this became new definition for velocity. So how we can read this? So this is nothing but the rate of change of velocity, sorry, the rate of change of position. X means position, the rate of change. So here rate of change means nothing but d by dt. So d by dt we call as rate of change, and x is nothing but position or displacement. So the rate of change of displacement, so that we call as velocity. So the symbol delta, sorry, the symbol limit delta t tends to 0 stands for the operation by taking the limit delta t tends to 0 of the quantity on its right term, means x. So it is in the language of calculus language, the calculus which is developed by Newton only. So the quantity on the right hand side, here it is right hand side is nothing but delta x by delta t. So the quantity present here delta x by delta t is the differential coefficient. My dears, this everything is the mathematical language, differential coefficient of x. So with respect to t, so here we need to develop a new method to find out the instantaneous velocities. So that is known as differentiations. So the differentiations can be done for a given function, so by using certain formulas. So here x is a variable, it can change, x is a variable. So d by dt is differential, or this is also nothing but limit delta t tends to 0 always. Now to calculate this we need to know certain formulas, so I can give those formulas first to calculate the differential formulas. So it is already there in our textbook, so let us take those formulas as first. Suppose if you want to do differentiation for a number, so d by dt of a number, so here number let me take as 4, so this number we call as a constant. So constant is nothing but it is not variable, it is not changing. The constant always remains same. So its value differentiation goes to 0. Or in a formula manner, if we can write that, so d by dt of constant c equal to 0. If you can do differentiation for any number d by dt of 1000 to a number, it always gives the differentiation value goes to 0. And d by dt of t, so the differential constant, not t, let me take a formula. Suppose you want to do, that is the first one, this is second one. Second rule is that, suppose d by dt of a function t power n. Now whenever we do differentiation with respect to t, so that is the variable should be present. So d by dt of t power n, it is something like this. So if it is, this is the one, what is the formula for this? This is the differential formula, goes to n into t power, so that is n into t power n minus 1. So let me talk about this formula example at here. Suppose take an example. Suppose if you want to find the d by dt of t power 9, so that is in this one. Here n equal to 9 and t equal to the variable t itself. So by using this formula, in the place of n I have to write 9, so its value goes to 9 times, and the t variable is the t itself, t remains like there, and the n minus 1. N minus 1 becomes here the 9 minus 1. So its value becomes 9 times t power 8. So if I ask d by dt of t power 9, what is the answer? You have to give 9 times t power 8. That is the answer. Let me take one more example. I can discuss this one today. Let me take d by dx. Usually the formulas wherever you find, that will be in terms of like this. So d by dx of x power minus 1. Now here we are doing differentiation to this variable, there is no problem. T power x minus 1. Suppose if we are writing like this, d by dt of x power minus 1. Now here d by dt is in terms of t, but here we got variable as x. So in this case we cannot do differentiation. I think I can write it here. Suppose if you want to do the differentiation d by dt for x power minus 1. So here variable is x, but we are doing differentiations with respect to t. So that cannot be possible. So that is wrong notation. So whenever we want to see the variable, so we have to do the differentiation to that variable. So we have to write always in terms of d by dx, differentiation with respect to x. Now if we can do that, I can apply the same formula. So d by dx of x power minus 1. So here this quantity we will take up that as n. So this is, we can take as n. We can substitute in the above formula. So the formula here I can write that d by dx of x power n is equal to n times x power n minus 1. So in the place of n I need to write minus 1, that is the minus 1 of x power minus 1 n value, and again minus 1 is there. So I can get minus 1 x power minus 2, which is also you can write minus 1 upon x square. So the value of d by dx of the value of d by dx of x power minus 1, which equal to minus 1 by x square. Okay, so this is the way to apply the differentiations. So like this, we are having certain formulas. By using the formulas for the differentiations, we can solve that. Now let us do one more example at here. Suppose, what is the value of, this color is not visible, take the d by dx of 2x square. So here the 2x square is a function and x is a variable. So how you can proceed? And we know that at here we know the two formulas. Suppose if you know the d by dx of 2, it's a constant differentiation goes to 0. And I was telling that you should not divide this like this. It means you cannot write d by dx of 2 and d by dx of x square. So like that we cannot do. If you do like that, this answer goes to 0, because 0 into something goes to 0. So this method is, we cannot do that. But what we can do, so we can rewrite this expression like this. So this I can write that 2, which is constant, cannot be differentiable. So that I can write the 2 outside, but I can do the differentiation for x square. So we can do the differentiation to x square separately. So this we can write that 2 times x square differentiations, again use the same formula. So I can write the formula d by dx of x power n. So the formula goes to n into x power n minus 1. So here n value goes to 2 times x power 2 minus 1. So if I can do that, 2 times 2 dot x, 2x, so its value becomes 4x. So the value of differentiation for d by dx of 2x square, which equal to 4x. So this is something new, mathematical techniques we need to use to find the instantaneous velocities. So this is nothing but the differentiations. So we are having certain rules. So we can use those rules to do the much more differentiations. So finally I can say at here, velocity, new formula for velocity, instantaneous velocity, which is nothing but dx by dt. It is also nothing but the rate of change of position is known as instantaneous velocity. Or if you can take the speed also, the rate of change of position is known as instantaneous speed. So they both are the same. So this is the new technique I would like to introduce to calculate the average velocity. So biology students, don't be afraid. So this is new mathematics. Not only mathematics students, but they can adapt fast. But we will try some model problems for the better understanding.